Hello everyone. Today I will take you through yet another exciting topic of analytical reasoning, and that's number series. So in this session we will look at what are the various ways in which number series questions can be formed and what is the basic building blocks or the foundation that you require to crack a number series. So number series, as the name suggests, is based around numbers. Now the questions are framed in three ways. The first most frequent kind of questions which is being asked in the number series is finding the next one in the series. It usually looks like this. As you can see, there is a series 1, 2, 4, 8, 16, and you will be asked to identify what is going to be the next number in this series if the pattern is being followed. So there is a specific pattern here in which the next number is being derived. As we can see here, in this case we can see the next number is being achieved by multiplying the previous number by 2. Second type of variation in which you can see number series question is being formed is the number analogy. So it looks like this. So we have to see there is a certain relationship between 9 and 16, and we want to have the same relationship between 49 and some unknown number. So we have to identify that particular unknown number. And lastly, identifying the odd one out in this series. So there is a particular series given. All the numbers will follow some pattern. There would be one number which would not be conforming to that particular pattern. So we have to identify which is that number which is not conforming to that given pattern. So as I said, there is some building blocks or some foundation stones which would be helpful if we want to crack number series questions in a much lesser time. Okay, so one of the major building blocks for number series is the squares till 30. It is highly recommended that you remember or you can recall squares till 30 because there are a lot of number series questions which are framed around number squares. So here is a list of all the squares till 30. As I said earlier also, it is highly recommended that you remember squares of natural numbers till 30. Another foundation stone would be cubes till 15. So I'm sure you are aware of cube. A cube, you get a cube when a number is multiplied by itself 3 times. So as you know, cube of 1 is 1, cube of 2 is 8, 3 is 27, 4 is 64, 5 is 125, 6 is 216, 7 is 343, 8 is 512, 9 is 729, 10 is 1000. Then additionally, if we can do 11, 12, 13, 14, 15, that will be really helpful. Now, how to identify that what is the pattern in the number series? So this flowchart can help you a little bit. If you see in a number series, if you see the number series, the numbers are on an increase. Next number is higher than the previous number. Then again, if you can judge if the increase is slow, so you can conclude that addition is being used here. And if we see that increase is happening too fast, or the numbers, there's a huge gap in the previous number and the next number, then you can kind of infer that probably multiplication has been used. So if you see fast increase happening, that can lead you to think that okay, probably here multiplication has been used. If you see a constant decrease in the number series, again we will infer on the basis of if the decrease is slow or fast. If you see the decrease is slow, then you can conclude that probably subtraction is being used here. If you see there's a rapid decrease in the numbers, then it can help you to infer that division must have been used here. So first thing to identify when you see a number series, You see whether the numbers are increasing or decreasing. Then again you can see whether the increase or decrease is slow or fast. Now there are some common series, like there could be a series consisting of perfect squares. If you have a series like that, and I've just shared that knowing or remembering squares till 30 would be really handy. So here we can see a series here: 324, 361, 400, 441. So if we look closely, they are nothing but the perfect squares. 324 happens to be 18 square, 361 is 19 square, 400 is 20 square, and 441 is 21 square. So following the logic, the next number should be 22 square and it should be 484. So there could be a series which could be completely based on perfect square. Similarly, you can see a perfect cube series: 512, 729 and 1000. 512 is 8 cube, then 729 is 9 cube, 1000 is 10 cube. So next number should be 11 cube, and that is 1221. Then there are arithmetic series, wherein the next term is obtained by either addition or either subtracting a constant number to its previous term. What do we mean by constant term? Let's have a look at the example here. So here we have a series which was 4, 9, 14, 19, 24, 29, 34. And if we look at the difference between each consecutive terms, we would see that every time plus 5 has been added to get the next term. So we know after 34, if we want the next term, all we have to do is to add 5 to 34. So our next number in this series would be 39. Similarly, we can have a subtraction series wherein a constant number is being subtracted to get the next term. Now geometric series would be a series where the numbers are increasing or decreasing, and that increase or decrease is obtained by either dividing or multiplying the previous number by a specific number. So here we have a series: 4, 36, 324, 2916. So 4 and 36. 4 into 9 is 36. Then 36 into 9 is 324. 324 into 9 is 2916. And 2916 into 9 is 26244. So here a constant number has been multiplied. Similarly, there could be a series where a constant number is being a constant number is used to divide each term to get the next term. Then there are series called arithmetico-geometric series. So here we would see the alternate addition and the alternate multiplication. So the series that we have taken here: 1, 4, 8, 11, 22, 25. If we see the pattern, it is like plus 3 into 2, plus 3 into 2, again plus 3. So the next number should follow into 2. So the next number in the series should be 50. Then there are geometric arithmetic series. So that means first we would have multiplication and then we would have addition. The example that we have taken here is 1, 2, 6, 36, 44, 440. So if we check it closely, 1 into 2 is 2, 2 plus 4 is 6, into 6 into 6 is 36, plus 4 is plus 8 is 44, into 10 is 440. So here we are seeing that it's alternative multiplication and addition, but not by a constant term. even those number by which we are adding or multiplying, there is a constant increase of 2. So for next number, it would follow addition because the previous time we have just used multiplication, and 10 plus 2 would be plus 12. So we would have to add 12 to 440 to get the next term, and that would be 452 here. Then twin and alternate series. Here we can see more than one series in a single question. So if we consider this as one series, we would not find any meaningful pattern. But if we check closely, 3, if I add 5, I reach 8. 8 plus 5 is 13. So the next number in this series would be 18. And the alternate numbers are following another series. Here I am adding plus 6. 10 plus 6 is 16. So the other number in this series would be 22. So this is an example of twin or alternate series, where alternate numbers are following one series and the other set of alternate numbers are following another series. Then we have two stage type series. What do we mean by two stage? Let's have a look. 1, 3, 6, 10, 15. So here if we see the difference is 2, 3, 4 and 5. So the next difference should be 6. And if we go one stage below in finding the difference of 1 between 2 and 3, again 1 between 3 and 4. So that way. So the next number here should be 21. Then mixed series. So here we would see we've added 12 here. Then we have added 24, 48, 96, and if we go one step below, or we would see here we are not adding, rather we are multiplying. The difference is being increased because of the multiplication by 2. So the difference after 190 should be 192, and the next term should be 382. The next difference would be here 192, which happens to be double of 96. Let's solve some questions now and identify what kind of series is being followed in each question. So the first question, 256, 324, 400, 484, 576. If I remember squares, I can easily see this is nothing but a series containing perfect squares, because 256 is 16 square, 324 is 18 square, 400 is 20 square, 484 is 22 square, 576 is 24 square, and we can see we are in giving a gap of 2 in each number, and then we are calculating the square of it. So the next number in the series should be 26 square, and that should be 676. So this is a series based on perfect squares. Looking at the second one, 23, 29, 31, 37, 41. Here if we could see what we are doing here, if I see the difference, it is plus 6, then plus 2, plus 6 and plus 2. That is the pattern in the series. We are adding, but the terms that are being added are being alternated. So for one term we are adding 6, and for another term we are adding 2, and that is being done in the alteration. So after 41, for the next term we will be adding plus 6 here, we will be getting 47. Then the next series, 1, 4, 27, 256. Again, it has to do something with squares and cubes, because we can see a couple of squares and couple of cubes as well here, because 4 is 2 square, whereas 27 is 3 cube, and 256 happens to be 4 to the power 4. So if I generalize it like this, my next term should be 5 to the power 5. Now what exactly is 5 to the power 5? Is 3125. So my answer here would be 3125. So this was again a series involving squares and cubes. Let's have a look at another one, which was 30, 56, 90, 132. There in this series we can see an increase, and the increase is slow. I can't say that increase is very rapid, so that's hinting me that probably we have used addition here. So now if we check the differences, the differences is 26. Between 56 and 90, the difference is 34. Between 90 and 132, the difference is 42. So maybe at one go I can't see a pattern, but if I go one layer below, difference between 26 and 34 is 8. Between 34 and 42 is again 8. So the next difference I'll be getting by adding 8. So the difference should be 50, and the next number can be obtained by adding 50 to 132. So the next number in this series would be 182. So we have to go 2 layers down to find the pattern here. Another one, 68, 130, 222 and 350. Now one thing, I can see there's an increase, and the increase is fast also. So there's somewhere multiplication involved. Okay, but if I try and identify any constant term that is being multiplied, I can't see any such thing happening here. Another way to think of it, if you see there's a rapid increase, then probably squares and cubes must have been used. Now 68 is actually closer to 64. It is 4 more than 64. Okay, and 64 is a cube also, and 64 is a square also. Let's see if we can identify such kind of pattern with other numbers as well. 130 is closer to 125, and it's 5 more than 125. 222 is 216 plus 6. 350 is 343 plus 7. Now what commonality we can see between 64, 125, 216 and 343? They are perfect cubes. 64 is 4 cube plus 4. So the 68 is 4 cube plus 4. 130 is 5 cube plus 5. 222 is 6 cube plus 6. 350 is 7 cube plus 7. So the next number in this series should be 8 cube plus 8, and that should be 512 plus 8 should take us to 520. Looking at the next one, 0, 3, 8, 15, 24, 35. If we check the difference between each consecutive term, it's 3, 5, 7, 9, 11. I can see the difference has been increased constantly by 2. So the next difference should be 13. So 35 plus 13 is 48. This is a simple arithmetic series. So the next series, 8, 3, 11, 14, 25. We can't say there is a constant increase, because after 8 we are seeing 3, and that means there's a decrease here, and then we can see an increase pattern. But if we observe the pattern, then we can see 8 plus 3 is 14. 8 plus 3 is 11. 11 plus 3 is 14. 14 plus 11 is 25. So the next number should be obtained by 25 plus 14. So what we can say here, every term is obtained by adding the previous two terms. So 8 plus 3 was giving me 11. 11 plus 3 gave me 14. 11 plus 14 gave me 25. So the next number should be 14 plus 25, 39. Another one, 3, 15, 35, 63. Then I need another new number and then 143. Now if we check the difference, then I cannot see there's a trend of a constant term being added here. Also I cannot see a trend of constant term being multiplied here. But if you look closely, 3 is nothing but 1 into 3, 15 is 3 into 5, 35 is 5 into 7, 63 is 7 into 9, and we want one more number here, and then we have 143, which is 11 into 13. So what we are doing, we are multiplying the two consecutive odd numbers. So the number that should come in the place of question mark would be nothing but 9 into 11. 99 here. Question number 9 here. So here I can see there is a huge dip here. Straight off from 100 we have gone to 50. There is a decrease here, then there is an increase here, then there is a decrease, then increase. So this might be a combination series. So if we see closely, between 100 and 50, one relationship is that we are subtracting 50. Other relationship is we are dividing 100 by 2. So 100 divided by 2 we get 50. 50 plus 2 we are getting 52. 52 divided by 2 we are getting 26. 26 plus 2 we get 28. Now for the next term we should follow divide by 2. So here we should have 14. 14 plus 2, 16. So this follows my pattern. This follows the pattern which is given in the question. So the missing term here is 14, which is obtained by dividing 28 by 2. Question number 10. 50, 60, 75, 97.5. Then we have to identify the number at the place of question mark, and then 184.275, 267.19875. Now 50 and 60. 50 into 1.2 is 60. 1.25. Since we can see after a certain period of time we are getting decimals, that means we are not multiplying the natural number. In fact, we are multiplying the decimals here. 75 into 1.3 is 97.5. The next number will be obtained by multiplying 1.35, and that gives us our answer as 131.625, which is obtained by multiplying 97.5 into 1.35. And further term, here we can see there would have been a multiplication of 1.4, and from here to here 1.45. Since we can see there the decimal terms are being coming here, so the multiplication factor or multiplication number that we are using here would be a decimal number. That's where your thought has to go. Your thought should start running it like that. So this is the session 1 on number series, where we have learned the most frequently asked variety of number series questions. It's like finding the next one in the series by identifying a pattern. In the next session, we would be taking the other two kinds of number series, which are like number analogy and now finding the odd one out, or the number which is not conforming to the pattern given in the series. So thank you. Thanks a lot.